Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC. We do everything DIY, and today we're working on another LG multi-V unit. Thank you to everyone tuning into Jumperman Tech. We're working on another LG multi-V unit, and in our previous visit we got another bad compressor. So here's our recovery setup with a scale. We're going to start by recovering the refrigerant. And guys, I need your help. We just started working in this building maybe 2-3 months ago, and this is the 4th compressor and inverter board to go bad. Really would appreciate anybody's input as far as what's going on here. I'm going to start the machine, but first I'm going to put the dip switch 5 up. Let this thing do its thing, and we're going to go into service mode. Alright, so it says FUNC, function. Let's go click the right arrow to service, click the red button to confirm. Then we're gonna go to service number 3. It's gonna be vacuum mode. VACC. Now all the EEVs and solenoids are opening up so we can recover all of the refrigerant. Valves open on both sides. Purge. Let's turn on the system here, and we're gonna weigh in exactly how much refrigerant we're gonna get out of here. All right, just opened up the tank. It's already pulling a little bit, as there's no pressure in here and there's greater pressure there. Automatically it's gonna go. Let's start this up. Anytime I change the compressor, I always use my scale to see how much refrigerant's in here, because I have no idea. Only the installers know. It's based on pipe length and, you know, how many turns you take and all those things. So anytime I do change the compressor, I do not use this refrigerant. I always put in new refrigerant. I don't know what the last person did, but there's definitely a lot of problems here. I'm not taking that risk. We always put in a fresh batch. I believe that's the best way to go. So let's give it some time. This takes quite some time to recover. In our experience, it could take up to about 1.5 hours or so, maybe even 2 hours in some cases. At least, you know, coming into the building and setting up, about 2 hours just to recover the refrigerant. So while this is recovering, we're gonna do a couple of things as well.
2,000 years later.
All right, we're slightly below 0 psi-G, and we have 371 ounces, 370 ounces. That's about 23 pounds of refrigerant. All right, we're gonna kill the power. Wait 5 minutes for everything to de-energize in here, and we're gonna have to bring down the control panel so we can get to this compressor, because it's buried behind here. Took off the screws around here, remove these wires, make sure that's out the way, and we should be able to just drop this down. So let's do it. I think right there is okay. Take one side, I take the other. Let's lift it down. All right,
got it.
Lift up and bring it down. Oh, there's water in here.
Oh shoot.
Well, I mean, it does sit outside though, but yeah, there's water in there. Anyways, let's try to make as much room as we can. The jacket on here is so crispy. I mean, you literally go like that, it's crumbling. See that? That thing is so stale. Christian, go downstairs and grab a garbage bag. All right? I'm gonna take this off. This thing is done. This is just not good. That thing is finished. Why is that happening? Are these things overheating? And that's why we're getting poor resistance values when we do our Megohmmeter test, our insulation resistance. So as of right now, let's just take off this jacket. Oh, it's gonna make a mess in here. Let's take off this jacket, take off some of these wires. Gotta take off this thermistor, and I guess these little things right here I believe it's so it doesn't rub out, so these go against each other. So take off some of these and let's free this up. Just literally grabbing it and pulling it, this thing is just breaking apart in a million pieces. It's definitely overheating in here. I'm gonna start freeing some of this up, take off this thermistor. We gotta take off these things. So maybe some of this as well. And let's free this up. We can't have any of this insulation get into piping, so we're just gonna blow it out with nitro. We want to keep the roof clean, but we picked up as much as we could. This really has to get out of here. Okay, so to free this up, we're gonna move these wires out the way. Take off this thermistor so it's not melted. Take off our 3 wires for the compressor. Remove these 2 wires for oil. And remove this cable right here. This is our heater, crankcase heater. Alright, so we have a lot more space to work with now. What I'm gonna do is actually cut out all of these fittings. And before I cut it, I'm gonna sand it down. So even then we don't get anything inside the piping. It's just a safer method. One thing I noticed is this thing looks really expanded. It is what it is. Let's go ahead and cut the pipes. It's not a regular compressor. Typically you only have 2 connections. You have 1, 2, 3, 4, and 5. We got everything sanded. Now we're gonna try to preserve as much pipe as we can, and let's cut it out. Alright, we took out the 4 bolts for the compressor holding it down, and all the pipes are cut. Let's go ahead and take this out. Just follow with me just in case something needs to be moved, okay? Make sure I'm gonna be free to pull this out. Get that pipe out the way. This one. This one? Go. Okay. All right. This is how we gotta go to bring these compressors up. All the way through there. Bring it down, bring it down. Alright, we're gonna remove the Schrader valves from the system. Every time I open up the system, I always replace the Schrader valves because it's the little details that count. Sometimes this is the most common leak and we just don't want to have that issue, so we're going to remove all of them. And also while we're brazed, we're going to run nitrogen through the system so we have no carbon buildup. Alright, let's put these legs back onto the compressor, and then we're going to mount it in place and braze all our connections. Alright, got the new compressor in place. Let's go ahead and connect all of our piping and tighten down the bolts. Do you hear that sound? I'm trying to figure out what's that screeching sound. It's like a valve. One of the valves are opening and there's refrigerant squeezing through. It just sounds terrible. Leave a comment if you know what that is or have any idea. And here's our nitro tank. That one side connected, the other side open. I'm gonna open this. Purge, right? And let's adjust this to where we want to braze. Right there. Using wet rag heat blocking putty. just over here, so when I braze this, nothing melts over here. Connections are all brazed. Here are 3 new Schrader valves. Let's tighten this down. They have a suction line filter dryer in here, but unfortunately there's actually no filter inside there, and there's no guts inside there. The last compressor that we took out, we opened this up to try to change it, but there was actually nothing in there at all, and the guts weren't in there, so you can't even, we had the filter, but without the guts, like the spring and stuff like that, you can't do anything with it, so that ended up as being garbage. I'll send you guys a picture of that. And what I did notice is that there was some oil stuck in here. I wonder if they're having oil problems where the oil is not migrating properly. And you know, it's seizing these motors, making them run hot to where the, you know, amps go up and the machine shuts it down. So unfortunately, we're not going to be able to take any of this out. It might even be a good idea just to get rid of it, but we're going to do an acid test as well. Honestly, I've done it on the other ones, and there's no presence of acid. I really wonder what's going on with these units. Is it just a bad design and installation with the piping? All right, let's pressurize the system and check for leaks. We're currently using micro gas leak detector. Sprayed all the connections. Let's get the pressure up and see if anything, but I used the inspection mirror and it's looking pretty good. Brazing shut those connections so we can recycle that properly. Now I can put back the thermistor, all those little vibration things, put back some wires, and we can start this vacuum. Okay, everything's looking good here. Got that back up there. Let's bring this back up and sort everything else out. All right, let's do it. Let's carefully bring this up. Get it in the clip. Right there. Nice. We're good. Alright, we can wire the compressor. Get these 2 wires back on. And the crankcase heater. We got the cover back on. We got the system in vacuum mode. So we're gonna leave this overnight for a very good vacuum. Got my micron gauge on there. We'll come back in the morning to see where that's at. We're gonna start packing a couple of things up. As far as the inverter board, when we come back in the morning, we're gonna close the gauges, make sure our vacuum holds. And during that process of us waiting, we're gonna be changing the inverter board, and then we can perform the startup. So as far as right now, we're gonna pack up and we'll be back in the morning. Rise and shine. It's a brand new day. And that is a beautiful reading, 430 microns. We're gonna turn off the vacuum. We're gonna see if the vacuum holds. And at the same time, we are going to replace the inverter board, and then we're ready for startup. Okay, so we turned off the power, and just to open up this, we removed these 3 wires right here. Always take a picture. This is not the first time we changed this board. I will leave a link in the pop-up as to a little bit more of a detailed video on how to replace this board, but right now we're gonna swap this one out with a new one, the inverter board. Alright, we just disconnected all the wires. Let's pull this board out. There's a little clip here that holds it as well. So I just look at them, see if there's anything visible, but we really didn't. Some yellowing, some dark marks here, dark mark here, dark mark here. All right, let's clean up the old thermal paste and let's start setting up the new board. If you pay attention around here, you see how that's like clean? Every time I change out one of these boards, you got this little marking on here. Some people say that there was like flux left over in the factory and they didn't like wipe it off and like it overheated, but I'm really not sure. It is what it is. Let's swap it out. This is the heat sink compound that LG themselves recommend to use, so that's what we use. We just pretty much put a nice thick line going across, and when you put the board in and tighten down the screws, we're getting low a bit on this one, tighten down the screws, it's going to basically just spread it across evenly, just like that. All right, let's get the wires out the way. Place right there, I'll clip in, press down a little. All right, everything is neatly put back together. Heater, oil, main power. Definitely got to order another jacket for this compressor. That one was just completely destroyed. So we got the new compressor, we got the new inverter board, and we have new thermistor assembly that is part of a different video, my original troubleshooting video. That's what we came here to do until we realized there's more issues. So let's take out the scale and let's start charging this thing up. All right, vacuum's holding. I already purged. Scale out, let's zero out the scale. All right, let's charge it up. 371 ounces, that's what we're looking for. We're gonna let it take as much as it can, and then we're gonna start it up, and in order for the full charge, we need the compressor to start. System is out of the function mode. Got some pressure in the lines. Got 147 ounces. Hopefully one of the rooms are calling. I mean, it should be. This one condenser unit serves about 8 or 9 air handlers on the 8th floor, and there's, I believe, 2 branch boxes in between this and the 8 or 9 rooms. So from here we got the 3 pipes going down into a branch box, and from there it distributes piping into each room. So let's give this a few minutes and hopefully this thing starts. Didn't even hear this thing start. Look at that, pulling 8.7 amps. Charging through the low side. Let's get this pressure up. All right, that is beautiful. All right, everyone, everything is looking good. We got 351 ounces in there. We need 20 more. This tank is now empty, waiting for another one to be brought up. And honestly, I just have a few questions. If you guys watched my previous video on when I troubleshooted this, when I was checking that inverter board, and the compressor as well, it kind of gave me tricky readings. So when I had the wires connected versus when I didn't have it connected, it was just completely different readings. But in the end, I did determine that this is what we needed to do, change the compressor and inverter board, and that definitely did the trick when it came to that CH26 code. But I'm on the phone, well, I'm on hold. I'm gonna call tech support and just ask them a few questions, and I'm definitely gonna let you guys know the answers with that. So even though I got the machine running, it's always good to call tech support and learn as much as you can. They have all the secrets. Everything that we saw with troubleshooting this and everything, it's not in any manual. So you definitely want tech support's help, because they were actually the ones who sent me the documents in my email. So it is what it is. Well, we're gonna wrap this one up here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe. I'll catch you all next time.